All right, here we go with lesson 2 for week 4 of distance learning. We are still solving radical equations, but you'll notice the difference in today's lesson is that factoring will be involved when we get to step 3, the solving step. And so even though the steps themselves are exactly the same, step 1, isolate the radical term. Step 2, raise both sides to the power that cancels out the radical. And step 3, solve by factoring. You'll notice that step 3 has some additional things that yesterday's lesson did not, or the last lesson. The first is how it's a breakdown of how to solve by factoring. You have to get the equation equal to 0. You have to factor it using one of the methods we've learned, GCF or the cross method. Sometimes we call the cross method the HC method or grouping. Then you set factors equal to 0. That's also called the zero factor property, which we've talked about in class. And then from there, you solve each of those factors. So we're going to start out with real simple ones and then just add layers to them as we go. And yesterday's lesson, we did the top problem together, and I told you to pause and do the bottom one. And then we did the top one, and you did the bottom one. Today we're not doing it that way, so kind of switch your mind around. We're going to be working from left to right. I'm going to do the left problem with you and ask you to pause and work the right problem. So let's get started. So in number 1, square root of 9n equals 9. Your first step is still isolate the radical term. Well, what do you notice about this radical term in this equation? It's already isolated, right? It's already all by itself. That means there's nothing being added to subtracted on the left-hand side, and there's nothing being multiplied to that radical on that left-hand side. So step 1 here for this problem is already done. Okay? So step 2, raise both sides to the power that cancels out the radical. So here's the original equation. What power do you have to raise both sides? 2, right, to get rid of the square root? But what's up on that right-hand side that's different from the last lesson? It's not a number, right? It's a variable. So what happens after the squaring step, on the left-hand side, the power of 2 cancels out the root of 2, leaving us with just the radicand, the 9n. But on the right-hand side, I have an n squared. So that squared term is why we have to factor in this lesson when we didn't have to in the last lesson. Factoring is what we use when we're trying to solve quadratics, and that's what this is. A quadratic has a highest exponent of 2, and so that's what we're trying to solve here. So step 3 now, solve by factoring. And this is the basic method for that. The first part of step 3 is to get the equation equal to 0. You want to keep your squared term positive before you factor. And so what I'm going to do here is keep that n squared on the right because it's a positive over there. And so to get everything equal to 0, I need to move what's on the left over to the right. So we're going to subtract that 9n to both sides. All right, so I have n squared minus 9n equals 0. So now go up to the factoring, the bullets under step 3. We did the first one, get equation equal to 0. Read the second one. It says to factor. So the only 2 methods we're using of factoring today are GCF and cross method. Sometimes you might call cross method AC method. Sometimes we might call it grouping. It's the thing that starts out like this. What multiplies to AC and adds to B. Take a look at our, so going back to our problem, so you're either doing GCF or a cross method. Which one do you think we need here? That's right, we need GCF. And the reason why we know that is because there aren't 3 terms. There's just 2 terms. There's an n squared and there's a negative 9n. And so we want to factor out their GCF. What do they have in common? An n, right? So we're going to divide the n out of each of those. And we're not getting rid of it, we're just dividing it out. It's like distributive property in reverse. So it comes out, whatever they have in common comes outside the parentheses. Right? So now we have factored that left-hand side. There are 2 factors. Remember, factors are things being multiplied together. So my 2 factors here are n and n minus 9. So this is factored form. Go back up and read the bullets under step 3. We're now here. Set the factors equal to 0, and then we're going to solve them. So we break that up. We set that first factor, the n, equal to 0, and the second factor equal to 0. So for n equals 0, how do we solve that? Well, it's already done, right? But for n minus 9 equals 0, we just add 9 to both sides. And we have n equals 9. And then we have n equals 0 here. Okay, so there's 2 solutions. It's a quadratic. It has a degree of 2. That means it has 2 solutions. I want you to take a minute, pause the video, and I want you to work number 2. All right, so you should have paused and worked number 2 on your own. I'm going to work it here for you, but I'm not going to speak through the whole thing. I'm just going to show you my work pretty quickly. Let me clear this work out of the way. Booyah. All right. So isolate the radical term. That's already done. Raise both sides to the power. That cancels the radical. That means squaring both sides. Step 2, we just did. Step 3, solve by factoring. The very first bullet under step 3 is to get it equal to 0. Remember, you want to keep the squared term positive, so we're going to keep it on that side, wherever it already is. Okay. GCF, what do those 2 terms have in common? Just an x. They don't have any number factors in common. So we factor that out. We have this. We set each of those things equal to 0 and solve them. This one right here, we just add 8 to both sides, and that gives me x equals 8. And then the x equals 0 factor stays that way because there's nothing else I can do there. All right, so there's the work for number 2. Let's move on to number 3. You'll notice that this number 3, if you're comparing it to number 1, they both still have a radical on the left, and they both have a single variable on the right. But what's different about the stuff inside the radical, the radicands? What's different in there? Hopefully you noticed that in number 3, there's a second term inside the radical. There's a -6. Okay, this gives a whole different flavor to the problem. But the basic steps are the same. Okay, so we start out talking about step 1, which means isolate the radical. It's already done. Step 2 is to raise both sides to the power it needs to cancel the radical, which is squared. Oh my gosh, why is this? Oh, I got the wrong pen, sorry. User error. That's never happened before. Okay. So squared both of those sides. The left side, the radical cancels, leaving me just the radicand, which is 5x minus 6. And on the right, I have x squared. Okay. Step 3 is to solve by factoring. The first bullet under there says what? Get the equation equal to 0. So I told you to find the squared term and make sure it stays positive. So it's positive right now on the right-hand side. So leave it there. So if you're trying to get this equal to 0, then what's on the left needs to move over to the right to combine with that x squared. So I have two things on the left, 5x and negative 6. We're going to move both of those over by making them opposite. So the opposite of 5x is minus 5x, and I have to do that to both sides. And the opposite of negative 6 is plus 6. And I have to do that to both sides. So everything on the left cancels and gives me 0. And on the right, I'm going to write these in standard form. X squared minus 5x plus 6. So the second bullet under number 3, or step 3, says to solve by factoring. Well, this is not a GCF step. Okay, this is a cross method step. I know because there are 3 terms. So this is where we do what multiplies to AC and adds to B. Okay, well, here's our A. The A is whatever's in front of the x squared. So as a quick review of A, B, and C, this is A, this is B, and this is C. A, B, C. So when I say what multiplies to AC, well, what is A times C? A times C is 6. And what adds to B? B is negative 5. Two numbers that multiply to positive 6 and add to negative 5. Pause the video and come up with that. All right, hopefully you came up with negative 2 and negative 3. I'm going to solve using grouping because most of you like that method. You are welcome to do the shortcut swing method if you like, but I'm going to do grouping. And grouping says we did this. We take this middle term and we rewrite it with these two coefficients that we found over here. So instead of negative 5x, I'm going to write this, negative 2x minus 3x. And then I'm keeping the first term, the x squared, the same, and the last term, the positive 6, the same. Right? And now we do grouping. I will group the first two terms together and group the second two terms. And then we do GCF on each of those groups. So looking at the first group, what do these two terms have in common? An x, right? They both have an x. So I'm going to pull that x outside and write the quotient, or the leftovers when you do the division, inside. And you can check here by distributing that x back through and see if it matches what you started with. On the second group, what do negative 3x and 6 have in common? It's clear they have a 3, right? Don't forget, though, when that leading term, when that first term is negative, you want to divide out a negative GCF. So you want to take out a negative 3 of both of those. So I took out a negative 3. And that leaves me positive x, because negative divided by negative is positive, and negative 2. And so now we look at these two groups together and we say, hey, what do they have that's the same now? And it's the x minus 2, right? So I will do GCF on these now, where I'm pulling out an x minus 2 from them, and what's left over? An x here, and a negative 3 here. And now that this is your factored step. So then now we go to the third bullet under number 3, where it says set the factors equal to 0. Yeah, set them equal to 0. That will work. I don't think arrow would get you very far. I don't know what arrow is. I think it's a thing. You let me know if arrow is a thing. Okay. So, and then we solve. That's the last bullet. So x equals 2 and x equals 3. You pause this video and go work number 4. All right, so you've had time to work number 4. I'm going to work through it pretty quickly, just so you can see how it's supposed to go. I am squaring both sides. That gives me negative 2x plus 8 equals x squared. Step 2, that was step 2. Step 3, solve by factoring, which means I have to get it equal to 0 first. So I move everything on the left over to the right by doing the opposite. So I have 0 equals x squared minus 2x plus 8. This is where we factor, so I need to know what multiplies to AC, which is 8, and adds to B, which is negative 2. And you should have had negative 4 and positive 2, so that it adds to negative 2. So going ahead with our grouping gives me this. And by the way, it doesn't matter if you write negative 4x in front of the 2x or vice versa. As long as your math is fine, you'll have the same answer. So then we group. Okay, hopefully you noticed my huge glaring mistake that it took me forever to find. Right, let me erase all this, my apologies. I hope you didn't think you were going crazy. For whatever reason, I put plus 2x minus 8 correctly on the left and minus 2x plus 8 incorrectly on the right. So let's fix that right here. And then this problem will go much better. Hey babe, good morning. So x squared plus 2x minus 8. Now let's do our AC method. Group. By the way, I just told my daughter, if you heard me tell her good morning, it's after 2 in the afternoon. She just woke up. Or she's been awake in her bed for a while on her phone, talking with her friends. I don't know. I'm sure you'll know exactly what I'm talking about. Raise your hand if you don't get up till after 2. All right, so here are my factors, x plus 4 times x minus 2, set each of those equal to 0 individually, and solve each of them, and you should have x equals negative 4 and x equals 2. All right, so here's our last set of problems in our last leveling up. So looking at these, what do you notice is different about how these problems start than the last problem, the last two? Hopefully you realize that these are set equal to 0, and the radical has a minus n on the outside. Number 6 has a minus a on the outside. So these are the first time today that we have to do step 1, isolate the radical term. So step 1 does apply here, it did not apply yet. So for step 1, isolate the radical term, we have to add n to both sides. And now it looks just like the last problems. All right, since these two are just like the last two, I'm not going to work you through them as slowly, so I want you to just pause, work them out, then come back to the video and watch me work it out more quickly. Yeah, babe. All right, so raise your hand if you got n equals 9 and n equals 5. All right, very good. So even if you didn't raise your hand anyway, because what do I know? I can't see you. So there is number 5. Take a minute now, pause if you haven't already worked number 6. All right, hopefully you got A equals 8 and A equals 2. And then I want to talk for a minute about this alert that I have at the bottom on the back of your worksheet. Take a moment, read it to yourself, pause, and then come back to the video. It says there is one extraneous solution on this worksheet. And extraneous solutions are something we've talked about before. They're solutions that don't actually work. They're like fake solutions. An extraneous solution is one that doesn't satisfy the original equation. Go find it by plugging all of your answers into their original equations and find the one that doesn't give a true statement. Now, I'm going to show you an example of what that means, but this isn't going to actually be the one. If you were to go back up to the top of this page on number 5 and plug in, and if you were trying to check your solutions, okay, that means you take them, like one of our solutions was n equals 9, okay? So you take that solution back up to the original, and you put 9 in for the n's. And then you do the math and see if it gives you a true statement. If it gives you a true statement, then the solution works. If it gives you a false statement, then it's a fake solution, quote unquote, and it's called extraneous, and you get rid of it. You don't use it in your final answer. So here's how that math would look for this one. If I was taking n equals 9 and plugging it into the original equation for number 5. So there's me plugging 9 in for n inside the radical. And then outside the radical was minus n, but now I know I'm checking out whether n equals 9, so I'm plugging in 9. So inside this radical I'm following my order of operations, okay, your PEMDAS. So you do your multiplication first. 14 times 9. Well, 14 times 10 is 140, but you're taking one of the 14s away, so it's 126. And then to subtract 45, it's easier for me to subtract 40 first. That gives me 86, and then another 5 is 81. And then we still have that minus 9 to bring down. Well, what is the square root of 81? It's 9. 9 minus 9 is 0. So is it true that 0 equals 0? Yes. Since it's true, then we know n equals 9 is a solution. Here's how you would know something was not a solution. You plug it in, you do all this work, and then let's say you don't get 0 equals 0. Let's say you're plugging in something and you're testing it out and you get 0 equals 2. Well, that's false. This is the case that tells you when you have an extraneous solution. So your job is to go through all your answers and all the problems on this worksheet and find the one that's extraneous or false.